Hello. Okay, so today we are going to be talking about myoglobin, hemoglobin, and the Bohr effect. So basically what you have to kind of know is that the myoglobin stops at the tertiary structure, right? So it doesn't have a quaternary structure because it's only a single subunit protein. So remember the keywords there. Single subunit protein means tertiary structure. Multiple subunit protein means quaternary structure. So myoglobin is just going to stop at the tertiary structure because it is a single subunit protein. It has a very high affinity for oxygen, which is great because we need it to kind of be our shuttle, right? And so on the other hand, hemoglobin has 4 subunits, right? So it is a multiple subunit protein. Now, hemoglobin really doesn't want to bind on to oxygen. It's like, no, I don't want to. No, fine. That's kind of the cooperativity. So after you get the first oxygen molecule to bind, it changes the conformation of that hemoglobin. And so it makes it easier for the other oxygen molecules to come in and bind. So that's when you're looking at that graph, you have it be sigmoidal, okay? So it's really slow starting off, and then it shoots right up after that cooperativity. So it's basically things are working together to get those other oxygen molecules bound. So that's like a big difference between myoglobin and hemoglobin. Again, myoglobin stops at the single subunit protein at the tertiary structure. Hemoglobin, since it has multiple subunits, it's going to have a quaternary structure. Now, about the tense versus the R state, the silly story about that one is if you're tense, imagine yourself and you just ran away from the cops, okay? You're out of breath because you were just running, okay? And your hands are in the air because they say freeze, okay? So you're out of oxygen, low oxygen. You're in the tense state with your hands in the air, so it's your bent conformation, right? And then you also you got runner's cramps from running, so you have high acid, okay? And so that acid, remember, is going to be low pH and a lot of hydrogens, because remember the pH scale is based on how many hydrogens we have. If we have a ton of hydrogens, then we're going to have very low pH, like below 7, right? Where when you don't have a lot of hydrogen ions, then you're going to have basic, which are the bigger numbers above 7. So you're tense, remember, you just ran away from the cops, your hands are in the air, you're out of breath, low oxygen, tense state, and the acid or acidic environment is going to favor that. Now with the basic, okay, you're going to be laying on the beach with your arms outstretched, watching planes go over top of you while you're on the beach. Planar position, lots of oxygen because you're just resting, and you're in that relaxed state, and again, you're really grabbing onto the oxygen. The other thing that you really want to kind of remember, and it's very silly, but it's all your B's, better basic binding Bohr, okay? What does that mean? That the Bohr effect means that basically you bind better when the pH is basic. So whenever you hit a question, it's like, well, it's going to be more basic. That means the higher numbers. That means that you're going to bind to that oxygen with higher affinity with hemoglobin again. Okay, so just remember better basic binding Bohr. So whenever, all of your B's, whenever it's basic, you're going to bind better. Okay, so then that's going to be, favoring that relaxed state too, where the tense state is when you don't have the oxygen. So I hope that helps. So that's basically myoglobin, hemoglobin, and the Bohr effect. All right, thanks.